So let's go ahead and graph this first one. What kind of function is this? Linear. Good old y equals mx plus b. So where will we start by putting a point? Yeah, up 6, so 0, 6. So right there. And then what do I do to get like to my next point? Like how will I do my slope? Yep, down. Now let's try and stay away from over, like can we say left or right? Because that's perfect. Down 1, right 3. I know that sounds like I'm being super picky, but I hope you understand it's like one is one way and one is the other. So. Right, exactly. So we want it to be going down, like we want it to be decreasing because it's negative. So thanks for working with me on that. Because I feel like when we get to upper level classes, like we have to be picky with the notation. So I sound like I'm being super picky, and I kind of am because that's the class, but I don't want it to sound like I'm being completely hateful. Now, a lot of this isn't going to be too hard, so I'm going to leave most of this for you. The one thing that I do want to do here is the X-Intercept, because what I get all the time is none. I realize it doesn't touch on this graph that you're seeing, but do you understand that this line keeps going? Like it's eventually going to hit. So for the X-Intercept, you're going to set the equation equal to 0 and just work it out. There's some space right here off to the side. We're just going to set this equation equal to 0 and solve it. So I just took the whole thing, set it equal to 0, we'll solve it. Welcome back to Algebra 1. Make your Algebra 1 teacher proud. What would we do to both sides? Minus 6. The negatives will cancel. How do you cancel out a 1/3? Multiply by 3. You do the reciprocal, so we're going to multiply by 3. These negatives will cancel. Multiply by 3, and you get 18. Perfect. Thank you. That was the next thing I was going to say. You can't write x equals 18. It's an ordered pair, so it's 18, comma 0. Now, check if that makes sense. Like, if this line kept going, does it make sense it would be way out there at 18 somewhere? Like, logically? Like, what I'm saying is if you got negative 10, I hope you would be like, wait a second. You know what I mean? Like, just check. Okay. Again, I think the rest of that will go okay. All right, let's graph this one. What is this one called? Absolute value? My thing's starred over here. And it moved what direction? Careful, because it's kind of backwards. We went, I heard you say it. Right 5. Good. So go right 5, put a point. It didn't go up or down. So just right there. And then you can make a table of values and plug in more points if you want, but I'll usually just use that -3 as a slope. I know it's going to be a V shape, and because each side is linear, you can use that as a slope. So down 3, right 1. Now it'd actually be down 3, left 1 as well because it's symmetric. But you can just use that as a slope. Now, if that bothered you, you can, of course, go and make a table and plug in more values. Like, that's totally valid. However you get a right answer, because everyone thinks differently. Yeah. However you get a right answer is totally cool. Yeah, just remember, yeah, always write it down. Okay, so don't rush. All right, and the one I wanted to do on here, this one, because I think the rest of this is going to go okay for you, is the Y-intercept. Because again, for the same reason, people will write none, but you get that this keeps going. It's going to be way down here somewhere. Now for the Y-intercept, you're just going to plug in 0. So it's actually a lot easier. You don't have like a problem to solve. If we plug in 0, you'll buckled in. Ready? Here we go. 0 minus 5. Very good. Absolute value of -5. 5 times -3, -15. And does that make sense that it would be down here at like -15? Like, just make sure logically, you all have common sense, use it, okay? Again, I'm gonna go to like the tougher problem. I'm trying to do like the harder ones for you, so we'll do more on this page. So we're actually gonna do all of 3 and 4 together, okay? What is this one called with the double greatest integer? Good. So it's going to be that staircase. It moved up or down? Down 2, so go down 2 and put a point. And it was a horizontal stretch by 3. So the steps are still only going to be 1 unit apart, but we stretch them, here's my slinky. We stretched them like this. So they're going to be 3 units like wide. And just draw at least 3 of them. You can, of course, do more. I'll zoom way in on it. I only put domain and range on this one because a lot of this stuff doesn't apply, if that makes sense. Like there's no asymptotes, there's no maximums and minimums, there's no increasing and decrease. Like just a lot of that stuff is not applicable. You would be like NA for everything. So we'll just do domain and range. I think domain is actually kind of interesting for this. What you want to do is sweep left to right. Watch me point to it. If I start here on the left, do I have all these points? Yeah, and then this one picks up where that one left off. So still going left to right, do I have all these points? So do I lose anything? So it's actually all reals, and you will write it negative infinity to positive infinity. That is the notation. And you did that last year with increasing and decreasing. You're just going to do it for domain and range. Infinity and negative infinity always get a parenthesis. You can't bracket an infinity. Infinity is not like a value, if that makes sense. Like you can't have infinity of something. Follow me there? It's like an abstract concept. Don't think too hard about infinity. Like don't hurt yourself. You know, it's like. All right, and the range, we don't really have a good way to write that. I usually just write it in words. So do you see how we have like -2, -1? We would have 0, 1, 2, but we're lacking all of the decimals in between. Are you getting me there? Like we don't have a 0.5 or a 0.7 or anything. All we get are the integers. So it's all integers. Do you remember what an integer, like do you know what an integer means? Like when I say the word integer? Like it's a whole number, right? But it could be negative, like positive and negative whole numbers. It means you don't have a decimal or a fraction. So just all the whole numbers. All right, and we'll do this whole one so that we at least do like one full problem. What is this one called? Quadratic. Perfect. And how did it shift? Up, down, left, right. Down 3. It didn't go left or right, which is nice. So just go down 3, put a point. And then we want to get a point on either side. So I'm going to make a little table right here, just like off to the side. Now we're centered here at 0. So what number would you want to try and plug in? You want to pick something near 0. 1. Let's do 1. Don't overcomplicate it, okay? And here's the math you've got to be able to do without a calculator. Ready? We're going to plug in 1. Y'all strapped in? 2 times 1. 2 squared. 4 minus 3 is 1. So we get 1, 1. And then work smarter, not harder. Where can I put another point? Because if you know the shape of it, -1, 1. Because what's the shape? A U. It is very, very stretched out. Why? It was actually a horizontal compression. Like we took it and squished it. And do you remember when we went over how the horizontal ones affect things more than the vertical ones? Like it's more of an effect on it. So it got very, very squished. I feel so bad for her. She like hates her job on days like this. I swear. She can't get anything done because every 5 seconds she's making it up. All right, so we're gonna do all of it for this. Domain, you're gonna sweep left to right. Now look, I know it looks like those arrows are pointing like directly upward, but you have to imagine it going off the paper forever and ever. Isn't it gonna go left and right forever? Okay, so it's gonna be everything, negative infinity to positive infinity. The other way you can think of that is you can plug in any number you want. There's no rule about squaring numbers. You can square any number on God's green earth. Range, you're gonna sweep downwards to upwards. It's smaller numbers to bigger numbers. So watch me do this. Is there any graph down here? No. Where do we begin? -3. And is there actually a point there? So we want to bracket that. Now, let's have a conversation about the brackets and parentheses. I need to be able to tell what they are. I get people that'll try and do something like that on a quiz or test thinking I'll give it to you. I won't. If I can't tell what it is, I can't give you credit. Bracket your brackets and parentheses your parentheses, okay? So -3 is where we start, bracket that, and then does it go on forever? So infinity. Correct. You can't bracket an infinity or a negative infinity because it's not really like a value, so you can't say we're including that. Did you need me for something, or you're just hi? All right. Let's do the y-intercept next, because you can just look at the graph and see it. Where does this graph touch the y-axis? Yeah, and so we have to write it as what, though, because you can't just put -3. Good, 0, -3, because it's an ordered pair. I'm just going to come back to those because we're going to have to actually work that out. We'll get all the stuff that we can just get from looking at the graph. All right, increasing and decreasing. You're going to, where did I put the 100? You're going to have to read left to right. So I will point to it, just watch me. We're going to read left to right. What is the graph doing first? Going down, decreasing. So we are decreasing from the left side, so -infinity, until, I know it's like, is it 0 or is it -3? You're reading left to right, so you want to use the x value. And if it helps you to like label that point 0, -3 and see which one's x, which one is x? 0. So it's going to be -infinity to 0 is our decrease. And then we're increasing, it's going to pick up where this left off. So we're going to increase 0 until positive infinity. Good. So just make sure you go left to right is all it does. So it has to be the x value because you read left to right. So if it helps you to label that point and label it x, y, and like see that that's the x one. Okay, relative maximum and minimum. It's going to be this point right here, but which one is it, max or min? The minimum. So maximum, you can say none. You can write NA. You can put a frowny face. I literally don't care, but you have to write something on that line because otherwise, if you leave it blank, I don't know if you knew that it was nothing or if you just forgot to answer it. So put something there. Some people will write nope. Some people get silly with it. I don't care, but you have to put something there. All right. So relative minimum, you're going to flip this point around. It's -3 at x equals 0. And then the end behavior, it's no different than what you did last year. You're just going to get accustomed to this new notation. We write it as limit. So it's limit x goes to -infinity of the function. And I'm going to pause there and give you all a chance to write it down because I know it's new for you. And we'll give you another break when we finish this page, okay? Just stick with me until the end of the season. All right, so -infinity means the left side. Hey guys, where's the left arrow pointing? Don't overthink it. Up, so positive infinity. So it's saying the left side is going up. And then we're going to do the exact same thing over here, except it's going to be limit as x goes to positive infinity. That simply means the right side. So see how this one's -infinity, that one's positive infinity. This is the left side, this is the right side. Where's the right side going? Up, so infinity. We're going to go back and get the X-intercepts. I left them for last because we're going to have to actually like work for those ones. Do you see how there are 2 X-intercepts, but they don't like land exactly on a nice whole point? All right, how do we find an X-intercept? What are we going to do? Set it equal to 0. There's plenty of space over here to the side. Just set this equation, just take the whole thing and set it equal to 0. We're going to practice solving. This would not be an algebra 1. This would be more an algebra 2 problem. So make your algebra 2 teacher proud. Oh no. I have full confidence in you. Well, here, I'll let you answer this first. What would we do to both sides? There you go. See, you got it. How do you undo a squared? And whenever, well, let's see if you remember this. Very good. Whenever you put a square root, what do you have to put in front of it? Good, plus minus. That's what takes care of the fact that there's two of them, all right? So we're gonna square root both sides. We'll have 2x equals plus and minus square root of 3. And then you only have one more step. Divide by 2. So the plus minus is what gives you both of them. Like there's two answers. So you get square root of 3 over 2 comma 0. And you get negative square root of 3 over 2 comma 0. I will type in square root of 3 over 2 real quick on a calculator just so that you know what that decimal is. Square root of 3, oh, whoops. Please. Divided by 2. Any guesses? It is 0.866. So we got 0.866 and negative 0.866. Does that make sense logically where it landed? Okay, because we're awesome. All right, I'm just going to do a couple on here and then I'll give you another break. What is this one called? Square root. So already in your mind, be thinking about what it looks like. It starts, well, the parent function starts at 0, 0, and then it kind of like does this. What direction did it move? Up 4. So we get the 0.04, and then I'm going to make a little table down here and we'll plug in some more numbers. If we plug in something that doesn't work, what do? Try again. Try. You don't get upset. You just try something else. All right. Now we have 0, 4. So you want to pick something near 0. What do you want to try? 1 times negative 1/2 would be negative 1/2 square root of negative 1/2. That did not work. 2 times negative 1/2 would be negative 1. Square root of negative 1 won't work, but you were closer. 4 times negative 1/2 would be negative
2.
There we go, negative 2. Why does it have to be negative?
Because negatives cancel.
Negatives cancel. So negatives cancel. You'll have a positive 1. Square root of 1 is 1. Plus 4 is 5. So negative 2, 5. And then I need one more. It will be negative. Good. So negatives cancel. 1/2 of 8. 4, square root of 4, 2, plus 4, 6. Negative 8, 6. And I'm just going to do domain and range for this one, because I think the rest would probably go okay for me. Because I just want you to get used to the new notation. Well, it's not new. You did it for increasing, decreasing. We're just going to do it for domain and range. Watch me point to it. I'm going to just show you everything. You just need to look at it. Domain, you're going to go left to right. Scanning, scanning, scanning. Okay, we have all these numbers, and it stops where? 0. Is there an actual point there? Yes. So it will be negative infinity to 0 with a bracket, because there's actually a point there. The situation where there wouldn't be a point there is if there was an asymptote. Do you know what I'm saying? Like, what graph has an asymptote? It looks like this. Actually, yeah, so when we get to that one, that'll be a parenthesis. All right, range, watch me point to it. You're going to scan downwards to upwards using the y values. Where do we start? 4, is there actually a point there? Yes, so bracket 4. And then I know it's not like going directly upwards, but isn't this going to keep on going upwards forever? Like, it's not in a great big hurry, but it's in, you know, that direction. So 4 to infinity. So number 6, I'm going to leave most of that one to you. I just want to do the Y-intercept because it comes out to a fraction, and I know that that scares people, so we'll go through that together. What do you plug in to get your Y-intercept? Hint, it's on the board. 0. Good. So we're going to plug in 0. Whatever it comes out to is what it comes out to. Okay? So look, 0 minus 3. Good. Negative 3 cubed. Negative 27. Good. So you end up with negative 1/2 times negative 27. Now, the negatives cancel, and you don't have a calculator. So you would just leave that as 27, half of 27. Just leave it alone. We literally simplify nothing in calculus because you don't get a calculator. So just literally leave it alone. I agree. All right, this one, I want to do the same thing. I just want to do the X and Y intercept because they turn out a little weird. How do you get your X-intercept? Hint, it's on the board. Set the equation equal to 0. It's going to be something, comma, 0. Now we have some space over here to the side. Just recopy that equation and set it equal to 0, and we will solve it. This would be, again, like a more algebra 2-ish kind of problem. You're going to be just fine. Pep talk. I do a lot of pep talking at the beginning of this class until everyone sort of finds their stride. I promise you'll get there. It's my favorite class to teach. So what would you do to both sides? Add 4. And then what? You got a 2 out front. How do you get rid of that? Divide by 2. So 4 divided by 2 is 2. Now here's the part that makes it more of an algebra 2-ish kind of question. How do you undo a cube root? You're going to cube both sides. 2 cubed is not 6. Please work with me. 2 cubed is 8. Good. So you get x plus 2 equals 8. And this actually turned out to a nice number. What's x? 6. But you have to write it as 6 comma 0 because it's an intercept. All right, Y-intercept, you're going to plug in 0. Leave a good amount of space for this one. Let me show, just watch. Let me show you, because this is awesome and you'll get used to it. Because you don't have a calculator, you'll literally do nothing. Ready? When you plug in 0, 0 plus 2. Let's try again. 0 plus 2 is 2. Cube root of 2. It's some number, but without a calculator, it's some crazy decimal. So we're going to leave it as cube root of 2 because we don't know exactly what it is. So your answer is 2 cube root of 2 minus 4. That's some number. Here, I'll type it in and tell you what it is. That really doesn't matter. Let's see, 2 cube root of 2. And then what was it? Minus 4. It's negative 1.4. Right, but like you, well, and then more decimals. Okay, you'll just leave it like that, and that's a great answer. All right, we'll do all of number 8 because these ones can get a little weird. What is this one called? Rational. Now, they're easy to graph because I'm not picky about them. All you have to do are get the asymptotes in the right place. So this shifted what directions? Right 3. So go right 3, dot that in. Can you guys see that okay? I made it blue, but it's not really that great. Right 3, and then it also shifted up 5. So go up 5, dot that in. And if it looks like the entire axis moved, you're right. That's essentially what happened. Now, did it get reflected or anything at all? No. So you're just going to draw it in like this. Just don't run into the asymptotes. I really don't care. Not grading your art skills. I'm sure it looks beautiful. So I think those are actually easy to graph because I'm not picky about plotting points. You just kind of go, good enough. All right, so we're going to do this whole thing because these can get a little weird. Domain, left to right. Now look, it goes left forever and it goes right forever. But who is not invited to the domain party? Who is getting left out? 3. 3 is a troublemaker. Kick him out of the party. Do you get what I'm saying? Leave 3 out. I'm going to write how you do this, and you guys can let me know if that seems familiar to you. You want everything negative infinity to positive infinity, but you want to exclude 3. So you go negative infinity to 3, union 3 to infinity. The parentheses exclude it, so don't bracket it. What this is saying is we want everything to the left of 3, everything to the right of 3, but not 3. It means union, but yes, it's like this and, no, sorry, that's an or. If it's like this, it's an and, I think. From geometry, we never use that. It's always you. Union. Does that seem familiar? Did you do that last year? Okay, I'm seeing some heads nodding, but range, it's gonna be the same thing. You go downwards to upwards. Who is not invited to the range party? 5. You're gonna write it the exact same way, except leave out 5. You're saying you want everything lower than 5, everything above 5, but not 5. 5 is a troublemaker. Kick him out. You guys did that last year in algebra 3. Oh, you did algebra 2 over the summer? Wow. You're impressing me. All right, let me come back to the intercepts. Increasing, decreasing. Yeah. Yes, you should. Okay. What is today, 28? There you go. Thank you. All right, increasing, decreasing. Let me finish this up so we have a little bit of time at the end. Reading left to right, just watch me point to this. Are we increasing or are we decreasing? And then over here still decreasing. So you are never increasing. Put none, put NA, put nope, put a frowning face. I don't care. Put something there though. A none, that's fine. Give me, never mind. I'm not even going to get into that. Now, the common mistake here is people put all reals. You're decreasing for the entire domain. 3 is still left out. So just copy over the domain. I usually get asked right there, will we ever copy over the range? No, because you have to read left to right. So it's always going to be the domain. The asymptotes are both easy and difficult. You have to remember which one's which. Vertical, it's going to be 3, but x equals or y equals? X equals 3. Focus over there, guys. Horizontal will be y equals 5. And then end behavior. You'll get used to it. Limit x arrow negative infinity of the function. Can I hear what your comment is? Yeah, what did you say about it? Oh. See how that works? All right, left end is leveling off at this asymptote, which is 5. Will it ever actually touch 5? No, but it's just behavior. It's just where's it headed? And it's headed towards 5. And then same thing on the right. Limit as x goes to positive infinity of the function is also going to be 5. All right, let's go back and get the intercepts. All right, X-intercept, you're going to set this equation equal to 0. I have some space right here, so I'm just going to use this space that I've got. Yeah, there's a fraction, so it'll be a little tougher. Let me zoom way in on that. We're going to set that equal to 0 and solve it. So what would you do to both sides? Minus 5. Now here's where this gets a little trickier. I would maybe give this a hug. What would you try to do next? Good, multiply over the x minus 3. You're going to multiply that to the other side. So you'll have 1 equals, and you have to do negative 5 times this. You have to distribute. It'll be negative 5x, and then plus 15. Good. And now it doesn't look so bad, because we got rid of the fraction. So then what next? How would we finish that up? We're almost there. Minus 15. 1 minus 15, negative 14. Negatives cancel, and you don't have a calculator, so just leave it 14 over 5, comma 0. Yay. I know you guys love fractions, so I'm going to try and put as many of them in there as I can. I'm trying to help you out. All right, Y-intercept will be 0 something. We're just going to plug in 0. If you put 0 right here, 0 minus 3. So that would be negative 1/3 plus 5. So negative 1/3 plus, now don't write 5. You need for there to be a common denominator. Here's the $1 million question. How many thirds is a whole 5? I heard it over here. Say that louder. 15. Or you could think of it this way. 15 divided by 3 is 5. So it's negative 1/3 plus 5. Just wrote it as 15 thirds. Anyway, that would be 14 thirds. Negative 1 plus 15 would give you 14. 14 thirds. I know you guys love fractions, so I'm just going to try and give you as many as I can. right, last page. Yeah, of course. All right, and we won't do too much with these ones. I'm gonna just go through this graph with you and the range. So what is this one called? Exponential? It's a swoop. It moved down 4. So go down 4 and dot that in. And we're going to make a table and plug in some numbers. If you pick something that doesn't work, you will simply try something else. But you want to try like 0 and 1 to like start out with. Like, let's try 0. I think 0 will work. You can't negative a 0, so find 0. What's 2 to the 0? Good, we're there. We got that. 1 minus 4. Awesome. 0, negative 3. You can like feel yourself getting smarter with the calculator taken away. I love teaching this class. That happens for everybody and it's awesome. All right, let's try and plug in some other things. Let's do -1. Good. And do you guys see how you're picking better ones like on the first try now? Like it's so beautiful how that happens. All right. -1 will just be 1. 2 to the 1 is 2 minus 4, -2. Awesome. And then I want one more. Perfect. Negatives cancel. 2 squared is 4 minus 4, 0. Why is it swooping downwards? But why downwards? It flipped. I just want to do the range. The rest of that won't be too hard. Range, you're sweeping downwards to upwards. So we're going to go from 4, so watch me point to it, 4 to infinity, but the 4 gets a parenthesis, not a bracket, because there's not actually a value at 4. It's an asymptote. Do you get what I'm saying? Oh, yes, thank you. I'm sorry. We got to look after each other. Negatives are the most commonly missed thing ever. They're slippery little devils. And the problem with missing one is, unfortunately, it makes your answer the exact opposite of what it was supposed to be. So it's like as wrong as possible if you miss a negative. We'll do all of the logarithmic one because I know that that's hard. So it's a sideways swoop. There's going to be a vertical asymptote. Did it move left or right? Good, left 1. So go left 1, dot that in. Now, there's only one value I want you to be able to do at this point. I'm just going to tell you some others. Let's just write it here. Any log, and when I say any log, I mean log base 2, log base 7, log base 1,000,000. It doesn't matter. Any log of 1 is 0. We talked about that once before, but only once. So if you don't remember it, that's fine. But any log of 1 is 0. What does that mean we would plug in here to make this be 1? We plug in 0, right? So 0 plus 1 is 1. Any log of 1 is 0 minus 2, -2. So you get 0, -2. And I'm just going to tell you the other intercept. Like that's the only one I would want you to be able to do right now without a calculator. We'll do more on this later. The other intercept for this one is 3, 0. And it's going to look like this. And I'm sorry, there's a hole in the page. I apologize. It would keep going, but there's a hole there. That looks funny. Actually, we won't need to do all this. Let's just do the domain. I think the rest of this would go okay. Domain, if you sweep left to right, where are you starting? Not 0, but -1 and bracket or parenthesis. Parenthesis. Oh my gosh, you guys, kind words only, even to yourselves. You guys are so mean to yourselves. All right, and then we'll just do a couple of these. Let's do the increasing, decreasing, and end behavior for this one. Oh my gosh. Okay, let's do increasing, decreasing, constant for this one because it's going to be kind of a lot. I will point to it. Just stick with me. We're going to read left to right. What is it doing first? Decreasing. So we decrease from -infinity And what I usually get is, but Miss Cole, this arrow is pointing upward. It doesn't matter because we're reading, and left means negative infinity. You always start with, if you feel like you're going to mess that up, label the left side negative infinity and the right side positive infinity. It's left to right. All right, so we decrease negative infinity until where? -7. Yep, because we're reading left to right, so you want X. It is very tiny. All right, then what are we doing? And it would be under which category? Increasing. Good. -7 to -5. And I just use parentheses for all of these. Just parenthesize all of them. All right, then what is it doing?
Constant.
Yeah, constant. I like that word, plateaus. From, what is it, -5 to -2. And then what is it doing now? Decrease. So how do you add on to your decreasing answer? Union. Good. What would it be? -2 until 2. And then we're increasing again. So union on to increasing 2 to 4. And then constant union on to that 4 to infinity. You should start with a negative infinity and end with a positive infinity, and they all like link together. And then we'll just do the ends, because again, I want you to get used to this notation. Negative infinity is the left end, positive infinity is the right end. Just go ahead and set it up and then we'll answer it. So it's either up, down, or leveling off. Those are the only 3 choices. Where is the left arrow going? Up. So we will say positive infinity. And where is the right side? -3. Again, it's either up, down, or levels off. Those are the 3 options.